In each of these examples, try to find the final velocity of one object if you can look at the data screen and find the final velocity of the other object. Let's look at the motion of the center of mass. It hasn't changed. You can measure those angles. Here we have an inelastic collision. They're going to hit at the center of mass and then move on together. Find the final velocity of the two of them stuck together. Now they're settling down, approaching a final velocity. Watch what happens to the energy. There's internal friction. The momentum is transferred, but the internal friction absorbs the energy, turns it to waste heat. Let's look at the motion of the center of mass. The velocity of the center of mass before the collision is the same as the velocity of the center of mass after the collision, which is simply the velocity of that blob stuck together. Now they're going to collide but not quite meet at the center of mass. They're going to be offset a little. Well, this is what happens in car crashes all the time. Somebody smashes into a car and they spin around. Here we have an explosion of a cluster of objects. You have three masses. They're all going to shoot out from each other due to an explosion. Find the velocity of one of them given the other two. Now look, right now we have potential energy of 10.29 joules. After the explosion, we have a kinetic energy of 10.29. The total energy remained the same. Here's another problem, just for your practice. Let's see what happens to the center of mass. Watch what happens here. They pushed off of each other while they were moving to the right. Here comes the center of mass. It just keeps moving.